Hi Year 12s! This is a video to explain how to sketch the trigonometric functions sine and cosine. It is important to remember how sine and cosine are measured, so we need to consider the unit circle. We measure the angle theta from the positive x-axis line in the reverse clockwise direction, and the unit we measure theta in is radians. Each quadrant is divided up into 90-degree quadrants, which are the equivalent of pi on 2 radians. From this graph we can see that for the first two quadrants, the sine function will be positive, which is the equivalent of 0 to pi. For cos, we can see that it will be positive in the first and fourth quadrant, as that is where the x-axis is positive. This will be in the range of 0 to pi on 2, and 3 pi on 2 until 2 pi. Theta can also take on a negative value, which is just when it moves in an anti-clockwise direction. Therefore, we know for cos it will be positive in the range of negative pi on 2 to pi on 2. We can also see that sine and cos will both have the same maximum, 1, and the same minimum, negative 1. When it has a minimum and a maximum, which are both 1 apart from the average value, we say that there is an amplitude of 1. The period of the function is how long the graph takes to perform a full circular rotation, and in the basic function, that period is 2 pi. Once you work out the original pattern of a sine and cos function, the starting point, the period, and the amplitude, then you are able to sketch the graph. Let's take a look at the basic sine and cos functions. Here, we can see that the cos function is the same as the sine function, but shifted slightly, pi on 2 units to the left. We can also see from our graph that the same pattern is repeated continuously for both the functions. Once we have the basic form of the sine and cos functions in our head, it's time to look at the more complicated equations. In these equations, epsilon gives us the shift along the x-axis, where it moves in the reverse direction of the epsilon sign. The b component of the equation is the shift either up or down the y-axis. The a determines the amplitude of the equation, which, as we said before, is the difference between the maximum or minimum and the mean. We also need to determine the period of the function, which is how often the pattern repeats itself. The formula for the period is 2 pi on the absolute value of n. The final thing we look out for is any reflections. If there is a negative sign in front of the a, the function will be reflected in the x-axis. If there is a negative sign in front of the n, then there will be a reflection in the y-axis. Let's take a look at a question which asks us to sketch the function of 5 cos times 2x plus pi on 3 for the range negative pi to pi. Step 1 is to calculate the amplitude, which is just the number in front of cos, 5. Since there is no shift in the y direction, then we know also that our minimum and maximum will be negative 5 and 5. Step 2 is to calculate the period, which we use our formula from before. And we know that n is equivalent to 2. So we get a period of pi. Step 3 is to determine the y-intercept by setting x to 0. Here we need to remember our values of cos. So eventually we end up with a value of negative 5 on 2. Step 4 is to set the function to equal 0 to determine the x-intercepts. Now, this simplifies to 2 by x plus pi on 3 equals cos inverse of 0. And cos inverse of 0 is equal to negative 3 pi on 2, negative pi on 2, pi on 2, 3 pi on 2, and so on. The pattern of the cos function will continually repeat, so there will be infinite answers. However, over the domain negative pi to pi, there will only be a finite number of answers. So we will only take into account a few of the answers for now, the ones that are within the range. Therefore, 2 times x plus pi on 3 equals only those values of pi within the domain. These are negative 3 pi on 2, negative pi on 2, pi on 2, and 3 pi on 2. Then we divide both sides by 2, and then we minus pi on 3 to both sides, which gives us our final answers of negative 13 pi on 12, 7 pi on 12, negative pi on 12, and 5 pi on 12. Since negative 13 over pi is outside the domain, we eliminate that response. However, given that our function does have a period of pi, we would expect the pattern of 4 x-intercepts over this range. Our x-intercepts also have a habit of occurring in this function every pi on 2. If we extrapolate this pattern in the positive direction, we get another intercept of 11 pi on 12. Step 5 is to find the start point of the function, which is a shift of pi on 3 to the left. This is calculated by the pi on 3 in the cos brackets. Then all we need to remember is to flip the sign. This means that cos of 0, 1, will now occur at pi on 3, or when x equals 1.05. Here is our function using all of that information. Note that the pattern repeats itself twice, which is what we would expect from a period of pi. In the exam, it is perfectly acceptable to also label your x-axis as pi fractions, and much easier to do when sketching by hand. If we just follow these new amplitude and period rules, plus our usual graphing rules, then it is not too hard to graph these trigonometric functions.